The next of the 5 methods we're going to talk about is angle-side angle congruence postulate. It says if two angles and the included side of one triangle are congruent to two angles and the included side of a second, then the two triangles are congruent. Again, we see that word included. So let's look at our included side this time. The side is the included part. Notice how this side with this marking is touching both of the angles that are marked congruent. That's what means that this side is included between them, because those angles are on the ends of that line there, those angles that are marked congruent. They are touching that particular side of the triangle. It's very important distinction for us to know which method we're using. That's why I'm making such a big deal of it right now. So it says write the appropriate congruent statement. Again, the congruent statement is naming the triangles. The first one, again, the order doesn't matter. I'm going to say A, B, C. So I started at the angle with 1 marking, then I went to B with no marking, then I went to C, which has 2. So I'm going to try to repeat that pattern on the other triangle. D has 1 marking, so I'm going to start there, go to the angle with no marking, E, then go to the angle with 2 markings, F, D, E, F. When we start doing this, a lot of my students think that I'm just naming them in alphabetical order. That is just something that happened. It's a coincidence. It's not related to the order necessarily of how I am naming them. Remember that I am naming them so that the corresponding congruent pieces are lining up. A is matching with D. B had no markings and E had no markings, so those match. F had this double marking and so did C, so they match. So it's very important that you're very careful on the naming there. Here we have a proof and we've got parallel lines in this proof. Remember, please, that parallel lines are going to lead to congruent angles. And since we're given the parallel lines, we're going to start our reasons with if lines parallel, then, and then talk about the angles from there. So I'm going to kind of highlight my congruent lines that I'm using here. WU and YV are the first ones that we're using in this proof, so those are right here. And the transversal that touches them goes along right here. So the way that these lines are showing is going to lead me to some congruent angles. And so these green lines here, I'm able to see that the angle here at, let me move that, I can't see my letters very well anymore. At W is going to be congruent to the angle over here at Y. So you can see how they go from the first statement to the second statement using those parallel lines. The parallel lines were given to us, so it's given. And these angles, the way that they are related is that they're corresponding. So we're going to say if lines parallel, corresponding, angles, congruent. Then, so if then form, if lines parallel, then corresponding angles congruent there. The next thing in the proof is one of the other givens about another pair of lines. And I'm going to highlight those parallel lines. This line parallel to this line. And those are going to lead me to find that this angle here at C is congruent to this angle here at X. And so we've got angle UXW congruent to angle VZY, because there's more than one angle at X here, so naming it with 3 letters. Again, this is given. Those those parallel lines are given. And then the angles, it's if lines parallel. Again, these were corresponding. Be sure you write the statement. This is about as short as I could get it. Then we have another given item. And it's already marked in the picture, these side markings. Notice that the side that's marked is touching both of the congruent angles, therefore the side is between those angles, so when we're naming it, the angles surround the side, and so the reason is the angle-side-angle congruence postulate. The next of the 5 methods is hypotenuse leg theorem. This one's theorem, the others so far have been postulate. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. So in this picture, we've been given on the left, we need to do our congruence statement. Starting by naming the triangle on the left, however you want to name it. I'm going to call it ABC. And then the triangle on the right in this corresponding order. So A has that right angle, and over here D has the right angle, so I'm going to start with D. I went from A to B across the side with 1 marking, so I have to go across the side with 1 marking to E. And then I cross the side with 2 markings to C, so cross the side with 2 markings to F. Again, they face the same direction in this picture, makes it easy to do, but later it will be harder to do. Over here, they gave me that AC is congruent to AC. They gave me some perpendicular lines. Remember that perpendicular lines give you right angles, so AB perpendicular to BD gives you a right angle here, and ED perpendicular to BD gives you a right angle right there. To use hypotenuse leg in a proof, you must name your right angles, and then you must say that the triangles are right triangles. That's very important. It seems kind of silly, but you always have to do that. Don't forget to do both of those items in the proof. Then they also gave me that AC is a bisector of BD. What this means is the segment AC cuts segment BD in half equally, meaning that from B to C will be the same as from C to D. So I can see in this picture how I'm going to be using hypotenuse leg to prove these triangles congruent. They both have the hypotenuse marked, and they both have a leg marked, and they both have right angles. So let's get to our proof here. Line 1, that was a given statement. 2, those were also given. B and D are right angles. Definition of perpendicular lines. And then the triangles are right triangles. That's what I said. You got to be real careful to remember to do both of these lines. That's the definition of a right triangle. Then AC as a bisector of BD was a given statement. And then we're able to say that BC is congruent to DC by the definition of a segment bisector. We've seen a lot of angle bisectors. Here we're using a segment bisector. Then we're able to say that the triangles are congruent by the hypotenuse leg congruence theorem. The last method for proving triangles congruent that we're going to talk about is angle side. In this particular one, if 2 angles and a non-included side, very important there, non-included side. A non-included side will be a side that is not between those 2 angles. Notice how the sides that are marked are not between those 2 angles. And by that, this would be the side that's between those 2 angles, and in this case, the sides that are marked are not between those. So that's what they mean by non-included side. And that's the difference between angle-side angle versus angle side. One is between the others, and the other is not on that side, okay? So let's see, write the appropriate congruent statement here. So we're jumping straight into, congruent statement. They didn't give me much room, and then I have a proof. So the congruent statement, I'm going to write it above here, naming these congruent triangles. Name the first one however you want. Name the second one to match. So I had started at A, which had 1 marking. Then I went to B, which had no markings. So I need to follow that along over here. D has 1 marking and E has none. So we're going to start with D, E. Then I went from B to C across this 1 marked side. So I got to go from E to F across the 1 marked side. So A, B, C congruent to D, E, F there. Now we have our last little bit of these notes is this proof right here. We have nothing in this proof. It's totally blank, and we're going to fill it in. We are given that BE is congruent to BC. They've marked it. We've been given that A is congruent to D. They've marked it. Again, this is that bow tie picture, I like to call it. We've got our vertical angles here in the middle. We can see how we're going to have angle, angle, side. Notice that the side is not between the angles, so the S is going to be on the end of the statement instead of between the A's in the statement. And so we know our route that we're going to take. So I'm going to start it by putting my givens. I like to put them just all together. Saves writing. So the first statement is just my givens and that the reason is given. My second statement is going to be those angles in the middle. I'm going to say A, B, E. I've got to name them with 3 letters here because there's multiple angles there. I said A, B, E. I like to kind of match. So A matched with D, so I'm going to say D, B, C. Although you could have said C, B, D. It really doesn't matter for this statement. Vertical, angles, congruent. Where the order matters is when you're naming your congruent triangles. I've listed my 2 sides and my angle that are my 2 angles and my side that I'm using, so I'm ready to say that the triangles are congruent. They have named them up here in the proof statement, so just copy the way that they wanted it named. And then we already knew that we were using angle, angle, side for our reason. The side's not between them. So you're going to put angle, angle, side, congruence theorem for that reason there. And those are the 5 ways to prove triangles congruent.